pictures help a lot. All right, can everybody see that picture? So what's our goal? What are we trying to do?
Find the value of x.
Find the value of 1x, right? Okay. So if I have 4 of these over here, can I split this evenly over here and each x gets a part of this? Does that make sense?
Yes.
Okay, so what have we done to 56? We have
To divide.
divided it by 4, right? And that gives us each x is worth 14. Okay, now we're not going to always want to draw a picture. We're going to get to the point where we do it without drawing a picture. So do we know what a coefficient is? Have you ever heard that word before, coefficient? Okay.
Yes.
Coefficient is the 4. It's a number that is attached to the variable by multiplication. Jordan asked me, aren't these connected by multiplication? Yes, they are. How do we undo multiplication?
Division.
So we are going to divide both sides because remember, whatever we do to one side, we have to do to the other side. We're going to divide both sides by 4. 4 divided by 4 is
16.
4 divided by 4.
1.
16.
1. And that's what I want is 1x, right? Okay, and then what is 56 divided by 4? 14. Okay, here it is mathematically. Does that make sense to you? Here it is in picture form. To me, that helps me solidify what I'm doing. Okay, questions you have for me about that? Did anybody do it a different way?
I just did 4 divided by, I just did 56 divided by.
Divided by 4, And that's what I did, but I just showed you both sides. Okay, you're exactly right. Because you were probably thinking 4 times something equals 56. And I know if I do 56 divided by 4, I'm going to get that something. Anybody else think of it different? No? Okay. There's always more than one way to solve a problem. And as long as your way makes sense mathematically, I don't care what way you solve it, as long as you can explain your reasoning. All right, let me make sure I didn't mark somebody absent that's here. Amber. Riker. Christopher. Micah. Molly. Bree. Jacob Rock. Shania. Haley Summerall. Victoria. Okay.
Did you call my name?
I already got you, Jordan. I just called out the ones I didn't have. All right, let's see what we got going today. Today we're going to continue talking about scaled copies, but we're going to look at something else with them and see if we notice a pattern. There's Molly. All right. See if I can, I'll be in here so I can see you. Oh, there's Shania. All right, so we slowly get everybody in class. Okay, just as a review, scale factor is the number you multiply by to get the side lengths of a scaled copy. Remember, it can also be the distances, right? Distances inside. Do we ever multiply the angles by the scale factor? No, because if you change
No.
the angle, you're going to change what the picture looks like. All right, so if we call this figure A, and this is figure B, and it's a copy, what can you tell me about figure A and figure B? What can you tell me about figure B?
That they're going down
Down,
half of the percentage
down what?
that they are.
They're
Divided by 1/2.
It's divided by 2, but it's multiplied. Remember, scale factor is a multiplier. So is it multiplied by 2?
Yes. It's multiplied and divided by 2.
It's not multiplied.
If you switch the...
It's multiplied
by 1/2.
It's multiplied by 1/2. And what happens to it? Look at the original. Here's your original. Here is the scaled copy that's been scaled by 1/2. What happened to it? What do you?
Smaller.
It got smaller. Okay.
Smaller.
So whenever we multiply by a number less than 1, it is going to make a smaller copy. All right, so scale factors less than 1 make a smaller copy. And does that make sense? If we multiply something by 1/3, isn't it going to be 1/3 as big?
Yes, ma'am.
Yes, okay. All right, let's look at this one. We call this A and we call this B. What can you tell me about A and B?
They look exactly the same and they're same size.
They look exactly the same. They're the same size.
Different places.
What is their scale factor? What is their scale?
1.
1. So when we multiply by 1, do we end up with the exact same thing?
Correct.
And that makes sense. If this side was 5 and I multiply it by a scale factor of 1, this side is still going to be 5, right? Okay.
Right.
Scale factor equals to 1, it makes an exact copy. All right, let's look at this one. Tell me about A to B.
They're multiplied by 3.
Multiplied by 3. Riley, what did they do when they multiplied by 3? How did it change it?
I forgot to lower my hand.
Oh, okay. Anybody else want to answer? How did it change it when we multiplied it by 3?
It made it 3 times bigger.
Made it 3 times bigger. So when we multiply by a scale factor that's greater than 1, we are going to get a copy that is larger than the original. Pretty much makes sense, right? Okay. All right. So now we're going to look at this. Going from small to big, we have a scale factor of 3/2. That means 1.5. And that's what we would expect, that it's a number greater than 1. Now, what if I wanted to go from the large triangle to the small triangle? Could I figure out the scale factor? Sure can. It's 2/3. What do you notice about 3/2 and 2/3?
They are not the same.
Okay, they're not the same. What do you notice? What else do you notice? These two fractions right here. What do you
They're
notice?
flipped.
They're
They're both flipped.
Okay. Do you know what that's called when we flip them?
Inverted fractions or improper.
Well, this is an improper fraction,
Yeah, that's an improper fraction. What
right?
do you call
But
it?
when you flip it, it is called the reciprocal.
Oh,
Reciprocal.
I remember that.
Remember that word? Okay.
Yeah.
So when we're going from the original to the copy, we multiply it by 1 scale factor. When we go from the copy back to the original, you multiply it by its reciprocal. Okay? Does that make sense?
Yes.
I see some of you writing down notes. I'm very impressed. Good job. All right, so today's lesson, get out of this. Keep losing Candace.
Lollipop, lollipop, lollipop.
All right.